Hello, class. Let's pick up with 9.6 on page 568, solving rational equations. So you've been learning a lot about rational functions and then a lot about the computation behind solving and simplifying complex fractions. And so now, and simplifying the various expressions, I guess. And now we're going to be actually using those techniques to solve rational equations. All right, so the very first technique they're going to show you is this idea of multiplying both sides of the equation by the least, they call it the LCD, least common denominator, or least common multiple is really kind of what it is to make things a little bit easier for yourself. So let's look at example 1, and that's where they use that technique. So you have 4 over x plus 5 halves equals 11 over x. Okay, our natural inclination is like, okay, I guess I could get a bunch of common denominators, add these things, and and use my various algebra techniques to try to solve for x. But there's actually an easier way, and that would be multiplying by something that would help you get rid of the denominators here. So between x and 2, what's your least common multiple? Well, they don't have any common factors at all, so I would just multiply 2 and x, right, and get 2x. So what would happen if I multiplied everything by 2x? Well, so we're going to do this, 4 over, so we're going to distribute 2x across the parentheses, and we're going to, of course, we have to follow the golden rule. We've got to do the same thing on the other side. All right, so what is 2x times this? Well, of course, the x's are going to cancel out for this first term. And then I'm going to just have 2 times 4, right? And 2 times 4 is just 8. And then I'm going to multiply 2x over here. Well, the 2 and the 2 are going to cancel out, and I just end up with a plus 5x. And then over here, again, the x's are going to cancel, and I'm going to end up with 22. Now, isn't that a lot easier to work out? Oh, I dropped a negative. I didn't write this negative here. Okay, so it's a negative 22. Okay, all right, so now, I mean, you're just back to doing, normal algebra, which is very easy. This is negative 30, and so what's x going to equal? It's going to equal negative 6. With these types of equations, you definitely do want to go and put the check in and check these, because it is still possible to generate extraneous solutions that don't work in the original equation, and I think this does work. But you can just stick these in your calculator and actually just crunch the decimals and just see if that one side equals the other. All right, so let's move on to example 2. And this is one where they say, yes, you're going to have an extraneous solution, and they're going to show you how that can happen. Okay, so example 2 says, okay, I've got 5x over x minus 2. And that is equal to 7 plus 10 times x minus 2. All right, so what's my least common multiple between all of these terms that are in the denominators here? Well, it looks like x minus 2 is going to be it, right? So if I multiply every single term by x minus 2, let's see how that can make life easier. Okay, so that's going to equal, and I've got x minus 2 here, times 7, plus x minus 2 here, times 10 over x minus 2. All right, so first term, this is going to cancel, that's going to cancel. That's nice. That's 5x. Equals, distribute this, so that's going to be 7x minus 14. And again, this cancels, that cancels, and so then I have a plus 10. And wow, isn't that makes life just a lot easier, right? So I get a minus 2x equals negative 4. X is going to equal 2. All right, well, so this is algebraically a correct answer. However, when I go back and I plug that in right here to my original equations, what's going to happen here to the denominator? You are correct. It's going to end up resulting in division by 0. So this turns out to be extraneous. So we throw it out, and we have to say, since that was our only solution, we're going to say we have no solution then to this. That there's no solution to that. That's going to work into the equation. All right, now let's take a look at example 3. Okay, this is an equation with two solutions. Okay, is the example. And I have 4x plus 1 over x plus 1 equals 12 over x squared minus 1 plus 3. Okay, so in this one, we want to factor this right here so that we know what our LCD or LCM is going to be, least common multiple. So we got 4x plus 1. Nothing's going to change over here. But over here, this can be written, right, as x plus 1 times x minus 1. Difference of two squares, right? Plus 3. All right, so if I were going to multiply by the LCM, what would that be? Well, I already have an x plus 1 term. I have both this x plus 1 term, right? So that's 1 already. But I also need this x minus 1 term to get rid of this denominator, right? X minus 1, and of course this one's just 1, so that doesn't matter. All right, so I really am going to be having to multiply both sides of the equation through with this, okay, x plus 1 times x minus 1 to get the right things to sort of cancel out. So let's do that. And here, let me move that out of here. All right, so I'm going to multiply. My LCM then is x plus 1 times x minus 1 times 4x plus 1 over x plus 1 equals, and then I'm going to have x plus 1 times x minus 1 times 12 over x plus 1, x minus 1, and then times the same thing, I'm running out of room here, x plus 1 times x minus 1 times 3. Okay, all right, so let's clean this up a little bit and see what we have. All right, so right here, this x plus 1 will cancel out with that x plus 1. And so now what do I have? I have two binomials that I'm multiplying, so that's FOILing, right? So I'm going to have x times 4x. What is that? That's going to be 4x squared. My tablet's all of a sudden deciding to lag. 4x squared, and then times x, which is x, minus 4x, so that's going to be a minus 3x. And then minus 1 times plus 1, that's going to be a minus 1, okay? And that's going to equal, okay, now this is nice. This cancels out right here with this, right? So that's 12. And then this is really x squared minus 1 times 3, right? So that's going to really be 3x squared, if I were to refoil all this, okay? And then it's going to be minus 3. All right, so now I just need to combine like terms. This looks like the highest degree is going to be a square. It looks like I'm dealing with a quadratic. So I'm going to bring everything over to one side. So I'm going to subtract 3x squared from both sides. I'm going to subtract 12 from both sides. Oh, I should have probably combined that. And then, of course, I'm going to add 3. Okay, add 3 to both sides. Okay, all right, so what do we got then? Well, we're going to have x squared minus 3x, and then I'm going to have minus 13 plus 3, so that's minus 10, and that equals 0. And let me just make sure I'm getting the right thing. Okay, yes. All right, so now you're down to a quadratic, and what's in your quadratic toolbox? You've got factoring, you've got completing the square, you've got the quadratic formula. Well, let's try the easiest thing, which is factoring. Let's see if that works. Are there any factors of negative 10 that combine into negative 3? And the answer is yeah. It's going to be x minus 5, right, times x plus 3. Plus 3 and minus 5 equals 0. So what does x therefore equal? X equals 5 and negative 3. All right. Oh, no, I'm getting this wrong. It's plus 2. What am I saying? That would be 15. Yes, you're right. Dumb mistake. Here we go. Yeah, so it's x equals negative 2. I don't know why I was coming up with a 3. I was looking at this. Okay, so those are the two answers. Now, if you were to go back to your original equation, you want to try those in and make sure that they work. I'm pretty sure they do, and because nothing's going to be turning anything into 0 in the denominator, so I think we are good on that. So the two solutions are going to be 5 and negative 2. All right, now let's do example 4. All right, and the next technique they're going to talk about is cross multiplying. So cross multiplying is kind of useful. um, and all right, so we have, this is our rational equation. We got 2 over x squared minus x. This works when you really have only kind of one term on each side, where it's, you have a rational, you have rational expressions on either side. All right, so remember we can cross multiply and set. So remember the means equals the extremes and all that sort of business. That's what we're doing here. So I'm going to say 2 times x minus 1 is going to equal 1 times this, x squared minus x. Okay, and so here I get 2x minus 1 equals, minus 2. I'm going to shoot to the second term. Equals x squared minus x. Okay, and let's bring everything over to the other side. So minus 2x because we've got a quadratic. All right, so, and I'm going to flip everything around and set it equal to 0. So x squared minus 3x plus 2 equals 0. Okay. All right, so I've got a quadratic again that I am solving, and I'm going to try to factor it. That's usually my first line of attack, and then if that doesn't work, then quadratic formula or completing the square. So I need 2 factors that combine into positive 2. That multiply into positive 2, but combine into negative 3. And that's going to be negative 2 and negative 1, right? So it's x minus 2 times x minus 1 equals 0. So x is going to equal 2 and 1. All right, now notice, if I put a 2 in here, everything's hunky-dory. But what happens if I put a 1, like up here? 1 squared is 1 minus 1, right? That's going to be 0. And then I'm going to have 1, minus 1 here, and that's a 0 there. So 1 turns out to be extraneous, and 2 is the only solution here. And also, if you would look at the book right now on example 4 on page 569, notice that they said that another way to check this would be to graph both sides of this equation. You would graph the left side into y sub 1 and graph the right side into y sub 2, and you would see where they intersect one another. And if you do this graph here, there goes Augie. If you do this graph here, you would notice that you don't have this as a solution anyway. There ends up being an asymptote at x equals positive 1, in fact. But you can see that they do intersect at x equals 2. So there's a graphical way of sort of checking this type of problem if you would like to use that and to verify extraneous results. All right, come back in the next video and we will wrap up this section.